Yeah, that's fine.
Now, one of my other hobbies is I have a marine tank at home. I'm very, very keen on corals and reef systems. And they've been in a lot of trouble recently. There's a lot of coral bleaching, sea change is affecting them, it's very bad. But the future of saving them is going to resist on machines like this. If you look down there, check it out. That is called a Sea Float, and here's the man who's making the one. You tell us all about it.
Hello there. So the actual underwater rover there, the underwater remotely operated vehicle, is called a Sea Perch, and basically it's something we're creating with high school kids, taking a lead from a 1954 published book, which shows you how to make these things. We're now seeing the US Navy actually do it as an outreach project to get science and engineering into schools, a whole STEM activity. So in a little school in Norfolk, Archbishop Sancroft School in Norfolk, we've taken this on. I'm just a parent. I wanted the school to be more involved and more ambitious. So we started building these in a 30-minute lesson at Monday lunchtime. We've got all series of things now, microprocessor controlled joysticks and the robo float, which basically comes up and down using a simple syringe and a linear actuator. We're all building with .NET Gadgeteer, which are this modular electronic system. We have a main board and then the ability to join in various other circuitry just using ribbon cables.
Really?
And yeah, it was published by Microsoft Research and made an open hardware, so you see lots of manufacturers for it now.
So now that's an interesting one, because Microsoft haven't been at the forefront of the sort of open source side of things, but they're doing open hardware now.
Yeah, so the Microsoft Research team, we produced Gadgeteer. We've got Seed Studios and GHI Electronics actually building it, so you can go along and buy this stuff. The reference designs are all published, so we've actually met people that are manufacturing their own stuff. But more importantly, the tools to write the software for these are all free from Microsoft. You need Microsoft Visual Studio C# Express, and then the Gadgeteer SDK, and then you've got a design service where you can add from the toolbar all your various components and modules, and the computer shows you how to wire them up, and then you can just do programming.
Okay, so that's interesting, because in my other life I'm a web developer, and you know, C# and things are tools that you find around your web studio for authoring apps online, building online services, connecting up servers. So we've got everyday sort of software skills there, and I'm looking, and I can see some PVC pipe there.
Yeah.
Yeah.
So basically, the key thing, you're absolutely right. We're using C#, everyday programming language. The Visual Studio C# Express is the free version of a professional tool set that myself as a software engineer uses every day in my profession. But the children are able to learn real development skills. But at the same time, with Gadgeteer and the availability of all sorts of simple things like the PVC plumbing materials, it means that we get this instant gratification, because children can actually construct some really advanced things very quickly, and they go from zero to something working in probably less than an hour.
And if you're wondering why this is so important, these tools will eventually be able to go under the sea and repair coral reefs, which is very important, because if the coral reefs die, the sea stops working, and if the sea stops working, we'll all die. So these technologies have a real forefront of green engineering, but there's one question I've got to ask: how do you waterproof them?
So there's two answers to that question, because if you're able to afford brushless motors, then you can forget waterproofing. The brushless motors just work in water. Completely counterintuitive for everything we've done, but they do. So
would they be with magnetic impellers and things like that?
Well, not even yeah, that sort of thing, but not necessarily that advanced. On the large yellow float and the blue open ROV over there, they're actually using brushless motors. So it's a different way for the motor to work. It doesn't need waterproofing. On the Sea Perch, we get sort of ingenious with black insulation tape to seal the motor. Then we put it inside an old 35mm film canister and fill the void with wax, sculpture's wax, all around it. And then you've just got the spindle exposed. And so there's very little opportunity for the water to enter the motor. And we end up with very cheap motors working very well.
Okay, and just to say it one more time, this is being made by children?
This is being made in a 30-minute lunchtime club. The children are aged 11 to 13. They've used basic design and technology skills to construct the chassis of the subs, some basic soldering skills, and now we're moving into more advanced microprocessor electronics, where they're actually achieving some really fantastic stuff.
That is totally awesome. Thank you very much. What's your name?
My name's Paul Foster. I'm a software engineer at Microsoft.
Hey, fantastic.